Hi student, now we are going to see the second section of thin layer chromatography. In this we will see about the how to do the TLC, the practical part aspect of TLC, how to run the thin layer chromatography. So there are four steps in which you have to follow when you are doing thin layer chromatography. The very first one, prepare the developing container. The next step, you need to prepare the TLC plate. Then third, you need to take care to spot the TLC plate. Fourth, develop the plate. Fifth, visualize the spots. So let us see about the preparation of developing container. So what is basically developing container? It can be a specially designed chamber, a jar with a lid, or a beaker with a watch glass on the top. Pour the solvent in the chamber to the depth just less than zero point 0.5 centimeter. Why do we need to have a solvent to the appropriate height? Is because the sample which you are spotting onto the TLC plate must not dip into the solvent which you have kept for development. So what happens if it is too high? The sample which is spotted on TLC plate may go and dissolve into that, and you will not able to attain the proper separation, or you will not able to do the separation of a compound. So make sure that the solvent is not too much into the chamber. And again, we have said that the chamber must be covered. It is because to attain the equilibrium. If the equilibrium is not attained, the sample may find difficulties or informity to do the migration when the separation is happening. So make sure the sample is saturated. To add into the saturation of TLC chamber with solvent vapor, you can line part of inside of the beaker with a filter paper. Cover the beaker with a watch glass and seal it gently. This is how we prepare the developing container which is going to be used in TLC. Now next is to spot the TLC plate. See, this is very technical, right? The spotting of TLC plate is not so easy as it look like. You must be always watchful when you're spotting the sample. It should not be so diluted, or it should not be so, it should not be over concentrated. So make sure that prepare a 1% solution of drug dissolving in volatile solvent like hexane, ethyl acetate, or methylene chloride. This is called DCM. And then the dip the micro cap or microcapillary into the solution and gently touch to the end onto the paper or the location of TLC plate. Do not allow the spot to be too large. If necessary, you can touch it to the plate, lift it off, and blow it on the spot. If you repeat this step, the weight area on the plate may stay small. So this is how you have to spot the TLC. Why when we are not spotting the TLC, what it can lead to? When you don't spot the TLC plate properly, it may not able to make you it may not able to make you a proper RF value which help you in determining or recognizing your sample. So make sure the spotting a sample onto TLC plate is very challenging, and it must be properly done. You must be very watchful because the amount which you are spotting on TLC plate must be washed before you spot onto it. In the next step, what we do the development. Place the prepared TLC plate into the developing chamber or beaker. Cover the beaker with a watch glass and leave it undisturbed onto the bench top. The solvent will rise up to the TLC plate by capillary action. Make sure the solvent does not cover the spot. Allow the plate to develop until the solvent is about half a centimeter below the top of the plate, or sometimes 2/3 of the plate. Remove the plate from the beaker. Immediately mark the solvent front with the pencil. Why do you have to take this care? Because you need to calculate the RA value. So make sure that the place where the sample has run, it must be marked so that you can measure the distance and you can find out the RA value of the sample. When you are taking a development, make sure you are not giving a proper you are keeping it properly. You're not giving any shake to the solvent system. In such cases, what happens, the development may be affected when you find any sort of disturbance of your chamber and the TLC movement. So make sure all this is taken proper care. After the development of the TLC plate, you need to visualize the spot which has separated. So for the visualization, there is number of technique through which we visualize the spot. If the sample is colored or the spot is colored, circle them lightly with a pencil. Make sure you are not using pen anywhere, because it itself contains the organic material which may affect or which may hamper the separation what has happened onto the TLC. Most samples are not colored and need to be visualized with the UV lamp and or the iodine chamber. So what we do when the sample is not colorful, you need to look into the UV lamp and hold into the UV lamp over the plate and circle the spot what you see in the UV light. Make sure when you are handling the UV lamp, you wear a goggle. Do not look directly into the lamp. Protect your skin by wearing gloves because UV rays are harmful. When there is a other sort of separation which is colorful, but you know about what it is, these are the certain detecting agent which we are using for. When you are separating for alkalides, we use drag and drop reagent. When you are having a phenolic compound, we go for ferric chloride. When you have amino acid or amines or amino sugar, we go for 9-hydrogen detection. 3,5-dinitrobenzoic acid is used for the detection of cardiac glycoside. 2,4-dinitrophenylhydrazine is used for the detection of aldehyde and ketone. These are the chromogenic reagent for visualizing the thin layer chromatography, chromatograph which has developed after development and the spotting of the sample. So these are specific. There is non-specific method also through which we see the separated sample. The non-specific method to see the separated one is iodine chamber, sulfuric acid spray, UV chamber. So in iodine chamber, how do we prepare a iodine chamber? We take little of silica, we add little of iodine and mix it, and then the sample which has separated we pour into the iodine chamber, and then we shake it. What happened? The organic compound which has got unsaturated bond in that, the iodine will attach to that and will give you color compound. And then sulfuric reagent, if the compound is organic in nature, if you spray organic sulfuric acid on that, it gets char, and in UV you can see the spot in the UV light and you can circle it. So there is something called destructive technique and non-destructive technique. What is destructive technique? Destructive technique is a technique which the sample which has got separated is get damaged or you cannot recover during the process of identification is called destructive technique. For an example, sulfuric acid or treatment with UV. The treatment with iodine chamber, it is a destructive technique because sulfuric acid, the compound which has got separated, gets char, and in iodine it reacts with iodine to form UV color complex. Whereas in UV it's non-destructive method because it is just circled, you can revert it back or you can get it your sample which is separated, you can collect by proper method through which it can be collected. So these are non-destructive technique and destructive technique. For detail of all this we'll talk about in paper chromatography, what are the different method of destructive and non-destructive techniques. So these are the method through which we do the separation of a compound. Now what are the different method through which we do the developing of a chamber? The developing of a chamber means when you put the TLC, when you spot the TLC, how it is placed into the developing chamber. There are method called ascending development method, descending development method, horizontal development method, and multiple development method. In ascending method, the sample is spotted and the solvent moves against the gravity, and in the descending method, the solvent is at the top and the sample move against the gravity. So ascending method is slower and descending method is little faster. In horizontal method, the sample is kept horizontally and the solvent is kept horizontally and it is moving. In multi development, you need to run through two directions perpendicular to each other so that the separation happen proper. Multi development is generally done for a compound which has got very similar Ra value or which are isomeric in nature. So these are the different methods through which we develop the TLC chamber. And what are the application of TLC? It is used for separation of all classes, or it may be natural or synthetic in origin. It may be used for checking the purity of a sample as a purification process. It is used for examination of reaction for identifying organic compound, that the reaction is complete or not, or the new product has formed or not. It is extensively used for identification test and test for purity. So these are the different application of TLC. So what are the advantages? The advantage of TLC chromatography is TLC offer a saving time as compared to traditional paper chromatography. TLC is quite robust. It requires minimal equipment. It is sustainable technique or providing confidence in accuracy of result. It is also useful if the samples have a small volume, is available and does not require very huge sample. So these are the advantage, but there is a disadvantage of TLC chromatography. TLC cannot be distinguished between the compound of isomeric and enantiomeric in nature. Thin layer chromatography is a physical separation technique. Thus, it is unable to define distinguish between the chiral molecule. TLC plates do not require have a long stationary phase. TLC applies to only non-volatile compound, and thus it limits its